Hello friends, welcome to our channel AVP Chemistry class. Today's topic Fajan's rule. Fajan's rules are polarization. Both are same topic. This topic is based is in the UG TRB Chemistry Unit 1. The definition of Fajan's rule is the extent of polarization depends evidently on the polarizing power of the cation and the polarization of the anion. What's the meaning of Fajan's rule? In Fajan's rule, the one cation and one anion, the cation size is little small comparing to anion. So that cation is small size, anion is bigger size. The cation attract the anion towards itself. Okay, so that is polarization. So the cation attract the anions towards itself. That is the polarization. So the before polarization, the smaller cation, the bigger anion, no disturbance. Okay. After the polarization, the smaller cation attract the bigger anion towards itself. Okay, so that difference is extent of polarization. That difference is what? Extent of polarization. So the polarizing, the capability of the cation is the polarizing power of cation. Okay, so the cation attract the anions towards itself. So the anion is polarization of the anions. Okay, so that is definition. Okay, then this Fajan's rule, some rules based on it. So what's the rule? The rules regarding polarization. So polarization rules Fajan's rules. So the rules regarding polarization are known as Fajan's rule. ஓகே ஸோ போலரைசேஷன்னாலே நீங்கள் நினைக்க வேண்டியது ஸ்மாலர் கேட்டையான் பிக்கர் ஆனியான். ஸோ இந்த டயக்ராம் உங்களுக்கு நீங்கள் நினச்சிட்டிங்கனாலே இது ஈஸியாகவே ஃபைண்ட் அவுட் பண்ணிடலாம். ஸ்மாலர் கேட்டையான் பிக்கர் ஆனியான். ஓகே, த சம் ரூல்ஸ். வாட் ஆர் த ரூல்ஸ்? First rule is cations with smaller size. That is important point. Okay, the cation is smaller size. Smaller size. So the cation with smaller size. The cation with smaller size with higher polarizing power. So smaller size na the polarizing power is higher. Okay, so example beryllium chloride, magnesium chloride, calcium chloride and barium chloride. So this is cation and this is anion. Cation, this is anion. In same case cation, anion. Then this is cation and anion. This is also cation and anion. In all example, in all cases anion are same, chloride. Okay, but the cation is different because this is beryllium, then this is magnesium, then this is calcium and barium. Okay, so this order is beryllium, magnesium, calcium, barium, and this is alkaline earth metal. The second group elements, alkaline earth metal order. So the periodic trend is top to bottom. This is top and this is bottom. So top to bottom the atomic size is increases. Okay, so beryllium is smaller size comparing to magnesium and calcium and barium. Okay, so top to bottom the atomic size is increases. Okay, but in polarization, smaller size have higher polarizing power. So which one is smaller size? Beryllium. Okay, so the beryllium chloride is high polarizing power. Okay, so in polarizing power the beryllium chloride is higher than magnesium chloride, then calcium chloride, then barium chloride. Okay, what's the reason? The smaller size. Okay, so the smaller size have higher polarizing power. Okay, then next rule is anion with have larger size Okay, anion with larger size have high polarizing power. Okay. In anion means that indicates negative. Okay. In polarization, the cation have smaller size, anion in bigger size. Okay. So in the what's the charge of anion? The size of anion bigger size. In the anion with larger size have higher polarizability. Here calcium iodide, calcium fluoride, calcium bromide and calcium chloride. So in the case all the cations are same, all are calcium. Okay, but the anion is different. Here I to iodide, then fluoride, then bromide, then chloride. Here the halogen group fluorine, chlorine, bromine, then iodine. This is the halogen group. Top to bottom, the atomic sizes increases. The atomic sizes increases. Fluorine is small size compared to chlorine, then bromine, then iodine. So which one is bigger size? Iodine. So here calcium iodide is a larger size, so they have higher polarizability. So which one is higher polarizability? Calcium iodide, because the iodine is larger size comparing to bromine, chlorine, then iodine. It's not iodine, fluorine. Okay, so here calcium iodide is larger size, so they have high polarizability. Next, for effective polarization, there should be high charge on the cation or the anion. So this is very important, so note it. In size of the cation or anion is small and anion is bigger size, but the charge of cation and the anion both are higher. Okay, so not small. In cation, then anion both have higher charge. For example, in sodium chloride, magnesium chloride, then aluminum chloride. So in this is cation, then this is anion. So here all the anions are same, because the chlorine have -1 charge. Okay, here -1, 2 chlorine, so that is -2, but each chlorine have -1. Okay, here also the Cl3, so -1. Okay, so here cation charge is +1. Here sodium, magnesium, then aluminum. Okay, here this charge is +1, my magnesium is +2, aluminum is +3. So which one is have higher charge? Aluminum. So in cation or anion, which one have higher charge? That is high polarizing power. So this is the example for cation. All the sodium is +1 charge, magnesium is +2 charge, aluminum have +3 charge. So which one is greater charge? Aluminum. Okay, so that is the high polarization. Okay, next magnesium chloride and magnesium oxide. So here chlorine have -1 charge, but the oxygen is -2 charge. Okay, so the magnesium +2, here also magnesium, so +2. So the cation is same, so anion is different. Here chlorine is -1 charge, oxygen is -2 charge. Which one is greater? Oxygen. Okay, because the higher charge of cation or anion is directly proportional to polarization, because high charge of the cation, the anion also high charge. Okay, so here the anion, which one is greater? And the oxygen. Okay, so note it, high charge of the cation or anion, the both, so is high polarization. So charge எதுக்கு அதிகமா இருக்குதோ அதுதான் high polarization in both cation and anion. Okay. So 3 rules over. What are the rules? First rule is that size of the cation is small. Okay, size of the cation is small, size of the anion is bigger. Okay, but the charge of cation and anion is high. Okay, high means which one is high charge? That is the high polarization in both anion and cation. Okay, next pseudo inert gas configuration. This is also one. one important question. First, know the order. Okay. What's the order? NS2, NS2, NP6, ND10. இதில் என்ன தெரியுது? The s orbital is completely filled, p orbital is completely filled, d orbital also completely filled. So not n, s, p, d. Okay, mainly d10. So இந்த orbital completely filled, that is pseudo inert gas configuration. ஸோ இந்த 3 ஆர்பிட்டால் கம்ப்ளீட்டாக ஃபில் ஆகிருந்தால் அதுதான் நம்ம என்னென்னு சொல்கிறோம், சூடோ இனர்ட் கேஸ் கான்ஃபிகரேஷன். மெயின்லி டி ஆர்பிட்டால் இஸ் கம்ப்ளீட்லி ஃபில்டு. ஓகே, ஃபார் எக்ஸாம்பிள் ஜிங்க் குளோரைட், தென் cuprous chloride, zinc chloride, zinc chloride. So here chlorine, this is plus charge and this is minus charge, chlorine -1. So chlorine, here 2 chlorine, so here -2, then here +2. Okay, then zinc atomic number what? 30. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, then 4s, 3d10, 4s2. Here is certain 2 plus, so the adding of 2 plus, that plus indicates வந்து 2 electrons நம்ம remove பண்ணிடணும். ஓகே, ஸோ 2 plusனா 2 electrons remove பண்ணிடணும். ஸோ 4s ஆர்பிட்டால் வந்து remove ஆயிடுச்சு. ஸோ what we get? 3s2, 3p6, 3d10. So this is completely filled. Okay, so this completely filled s orbital, p orbital, d orbital, mainly the d10. Okay, d10 electron, that indicates pseudo inert gas configuration. Another example is cuprous chloride, CuCl. Here chlorine is -1 charge, Cu is +1 charge. So Cu plus, the configuration is 3d10, 4s1. So the 4s1 plus, that indicates the remove one electron. So what we get? 3d10. That indicates what? Pseudo inert gas configuration. Okay, next, the pseudo inert gas configuration elements have high effective nuclear charge. High effective nuclear charge but smaller radius, that is high polarization. What's the meaning of effective nuclear charge? Effective nuclear charge என்னது? Z effective. Already நம்ம படிச்சிருப்போம் lattice rule. Z effective is equal to Z minus S. Z effective, what is S? S is atomic number. Then S is screening effect or screening constant. Oh, shielding constant, both are same. This effective nuclear charge, அது என்ன சொல்கிறோம் அப்படின்னா, the effective nuclear charge that indicates in d10 orbital. This is one nucleus, then this is s orbital, then this is p orbital, and this is d orbital. Okay, so here electrons are there. வந்து இந்த எலக்ட்ரானை அட்ராக்ட் பண்ணதுக்கு நமக்கு நியூக்ளியர் சார்ஜ் வந்து அதிகமாக தேவை. பிகாஸ் ஹியர் த சார்ஜ் டிஃபரன்ஸ் இஸ் ஹை. ஸோ ஹை எஃபெக்டிவ் நியூக்ளியர் சார்ஜ், high effective, Z effective value is what? High. The smaller radius, why it is smaller radius? Here fully filled the electron. So the fully filled the electrons, D10 fully filled, P6 fully filled, S fully filled. So அது கம்ப்ளீட்டாக ஃபில் ஆகி இருக்கிறதுனால அதோட ரேடியஸ் வந்து என்னாகும், வந்து கம்மியாக இருக்கும். தென் ஹை போலரைசேஷன். ஸோ ஸ்மாலர் ரேடியஸ் ஆகும், எஃபெக்டிவ் நியூக்ளியர் சார்ஜ் அதிகமாகவும் இருந்தால் த போலரைசேஷன் இஸ் ஹை. ஸோ வாட்ஸ் த மீனிங்? சூடோ இனர்ட் கேஸ் கான்ஃபிகரேஷனுக்கு போலரைசேஷன் இஸ் ஹை. But the noble gas configuration, the polarization is low. That is the main thing. Okay, so what we get? Pseudo inert gas configuration, polarization is high, but noble gas configuration, the polarization is low. Noble gas configuration is, the order is NS2 NP6, NS2 NP6. So the s orbital and p orbital only completely filled electrons. not the d orbital, but pseudo inert gas configuration the d orbital is also completely filled, but noble gas configuration the s orbital p orbital is only completely filled electrons. For example, sodium chloride, sodium that atomic number is 11, here plus minus 1 chlorine, then sodium plus 1, so 1s2 2s2 2p6 3s 1, so plus charge, so remove one electron, so here we get 2s to 2p6, so that 2s to 2p6, so s orbital p orbital only complete electrons, so that is noble gas configuration. Example, sodium chloride and potassium chloride. Is here low effective nuclear charge because only s and p orbital. Comparing to pseudo inert gas configuration, noble gas configuration is low effective nuclear charge, larger radius. Then noble gas configuration have low polarization. Note it, that is important point. No, next. Properties of ionic compounds affect by polarization. What are the properties that affect the polarization? Ionic compound. What are ionic compounds? Example, here the AgCl. So AgCl dissociate in water, dissociate into plus charge and minus charge. So எந்த எலமெண்ட்லாம் பாசிட்டிவாக கேட்டையானாவோ ஆனையனாவோ வந்து dissociate ஆகுதோ that is ionic compound. Okay. Here AgF na Ag plus then F minus. That indicates ions. So they dissociate into ions, cation and anion, that is ionic compounds. Okay. What are the properties? The first property is the solubility of ionic compounds in polar solvent. So note it, that is polar solvent. What are polar solvents? The same HOH. This is what water molecule. So the water molecule dissociate into H plus OH minus. That the ion. That ion indicates polar. Next example is sodium hydroxide. Here this is plus charge and this is minus charge. That indicates polar. Okay, next chlorine molecule, here plus, here minus charge, here also minus charge, no plus charge. Okay, only minus charge is there, so this is non-polar. So dissociate ஆகும்போது plus charge minus that indicates polar. Only one charge, that are cation or anion, that indicates non-polar. Okay, so solubility of ionic compounds in polar solvents decrease with increase in degree of polarization. So the solubility is inversely proportional to polarization. Okay, the solubility is inversely proportional to polarization, but one condition, that is polar solvent. In polar solvent that indicates a plus and minus charge. So polar solvent ku solubility na enadhu, water or any solvent la adu dissolve agum, that is solubility. So the solubility is inversely proportional to polarization. Okay, so here and the AgF and the silver fluoride, silver chloride, silver bromide and silver iodide. So here cation is same but anion is different. Okay, so the anion order fluorine, chlorine, bromine, then iodine. Okay, so fluorine, chlorine, bromine, then iodine. So top periodic trend top to bottom is increases. Okay, but and here the inversely proportional. So in polarization, smaller cation but bigger anion. This is inversely proportional. So smaller size get polarization. Which one is smaller size? Fluorine. So fluorine, then chlorine, then bromine, then iodine. Okay, why this order? Because the solubility of polar solvent is inversely proportional to polar solvents. Suppose in non-polar solvents means directly proportional. This polar solvent in non-polar solvents means solubility is directly proportional to polarization. Okay, next. So first point is solubility order. So the solubility is inversely proportional to polarization. So the general rule, polarization is bigger size in anion, but here inversely proportional. So the fluorine get the more fluorine is greater than chlorine, then bromine, then iodine. Okay, next, the polarization of melting point, the polarization is inversely proportional to melting point. Okay, here also inversely proportional. What the sodium chloride and magnesium chloride and aluminum chloride. So generally the polarization of polarization, the charges cation and anion both have, which one have higher charge, that is greater polarization. So here Al3 plus, the aluminum is getting more charge plus 3, then magnesium plus 2, then sodium plus 1. In general, the polarization on the biggest charge is greater, but the melting point is inversely proportional. So that's the order is sodium chloride is greater than magnesium chloride, then aluminum chloride. ஜென்ரலாக எதுக்கு சார்ஜ் அதிகமாக இருக்கோ அதுதான் போலரைசேஷன் அதிகமாக இருக்கும். ஆனால் இங்கே மெல்டிங் பாயிண்ட் வந்து இன்வர்ஸ்லி ப்ரொபோர்ஷனல். ஸோ எது ஸ்மாலர் சார்ஜோ அதுக்கு தான் போலரைசேஷன் இஸ் ஹை. நெக்ஸ்ட்டு, polarization is directly proportional to covalent character. Polarization is directly proportional to what? Covalent character. So இதுக்கு முன்னாடி solubility வந்து polarization inversely proportional, then melting point also inversely proportional to polarization, but the polarization is directly proportional to covalent character. Okay, that example is beryllium chloride, magnesium chloride, calcium chloride and barium chloride. So here anion is same. Okay, then cation beryllium, then magnesium, calcium, then barium. So in polarization the cation size is small. Smaller cation, bigger anion. So smaller cation gets more polarization. So which one is more polarization? Beryllium, because top to bottom the atomic size is increases. Okay, but the polarization, the cation gets small size, that is high polarization. So beryllium is small size. So beryllium, then magnesium, then calcium, then barium chloride. Okay, because the polarization is directly proportional to covalent character. Okay, so continuation part next video. So இது மாதிரி யூஸ்ஃபுல்லான வீடியோஸ்க்கு please subscribe my channel. Thank you.